Good morning. All right, so today it's going to be pretty short. Just going to kind of go over what we're going to be doing next week. Just going to go over syllabus kind of stuff today. So next week we're going to meet in person in the physical lab room in Cal Poly. Today we're meeting remotely, but next week we're going to start meeting in person, and then I'm going to provide you that calendar that tells you which days we're going to meet. But like I said, you can plan on meeting most of the Tuesdays this semester. So I posted this on Canvas right now, so you can follow along if you like. So this is a hybrid course again. So we have 25 to 75% meetings in person for the lab. That's going to mean we're going to meet. I'm going to try to push it towards 75% for the lab, because that's where you're going to benefit the most, is getting the hands-on experience. So in the lab, it's even more important to get that, in-person instruction. So I'm going to push it more towards 75% for the lab. So we're going to get in teams of 2. You can hold off until next week, until we're actually meeting in person, before you choose your lab partner. That'd probably be best. We're going to try to get in groups of 2. I have to check the exact numbers. There might be an odd number, so there might be like one group of 3, but for the most part, I would like groups of 2. So there's going to be some equipment you'll have to get. If you don't have everything necessarily by next week, I might be able to loan you some stuff, but just try to get that as quick as possible. So there's a bunch of equipment down here on the bottom. Well, I guess we'll get to that in a moment. Let me just look at other parts of the syllabus first. Okay, so even though we're meeting in person, we still are going to be doing a lot of simulation. So we're going to be using the same tools that we used in 1021. So we used Multisim and PSpice, National Instruments Multisim and OrCAD PSpice. We're still going to be using both of those pieces of software for this lab as well. So we're going to try to make measurements in the physical laboratory, and then we're going to try to simulate our circuits using PSpice and Multisim, and then in some cases also the theory. So maybe do a calculation by hand, and then you'll have a lot of different ways to compare your data. So we should be able to, physically measure the circuit and then simulate it and do it theoretically and get a similar answer for all 3 methods. There is no lab manual for the lab. I'm going to provide you some handouts each week. So you don't need to buy any lab manual or textbook or anything like that. So every week I'm just going to provide you a handout. The grading criteria for the lab is going to be a combination, half and half combination of how well you completed the lab. In other words, did you make all the measurements correctly? Did you get the correct setup? And is your data reasonable? That's half of the grade, and then the other half of the grade is how well you've done your lab reports. So that includes both content and formatting and organization and those kind of things. Yeah, like I said in the lecture, everything you submit in this should probably be in PDF format. A lot of this stuff's kind of redundant from the lecture syllabus. Here's some information about lab reports. So I have kind of a rough outline of how you could do your lab reports, which sections you should have. You don't necessarily have to follow this exact format. You can just make sure that you have something similar to this, whatever you see fit for your particular, for that particular lab session. But you want to make sure you talk about the same information, I guess. And you can put it in whatever section you want, but as long as you have the similar information, it's going to be okay. All right, some of the labs are going to be more formal type of report, and some of the labs are going to be just a simple show me your data and your screenshots, that kind of thing. So if it's simulation, then you can take screenshots of your circuit, take screenshots of like scope screens or screenshots of graphs, for example, in PSpice. You can also, for like the physical stuff that we're going to actually be measuring, you'll just be recording that by hand or typing it in. A lot of people would typically use Word or Excel or something to just manually record their data. So you don't have to take pictures or anything of the physical lab setup necessarily. But for your simulations, it is a good idea to take pictures of your measurements, or at least a few. So labs will typically have about a week and a half, probably, or 2 weeks to complete the lab report. And like I said before, you're going to be getting in groups of 2, so it'll be 1 submission per group, not individual. And I'll let you know which lab requires a full, more formal type of report, and which lab is more informal and just requires the data. Okay, let me discuss the components here. I spent hours trying to put together some more recent links for you. So there are a few things you should try to buy. These are going to be things that you'll use in all other classes moving forward as well, hopefully. I know maybe you've already missed a chance, so maybe some of this stuff will get, maybe some of this stuff would be unnecessary given that some classes have already been missed, but it's a good kind of toolkit to have in general as a, electrical engineering type of student. So some of the things you need are a resistor kit. So a resistor kit is going to be a kit of resistors, as the name implies, but it's going to contain a bunch of different values that are common. And usually these kits range from about 1 ohm all the way up to 1 mega ohm. So they're going to give you an assortment of resistors between 1 ohm and all the way up to 1 mega ohm. So I have a few links here. Hold on a second. Okay, so this is Jameco Electronics. They're in the Bay Area somewhere. They're a pretty good option for ordering electronic components. You can also use Amazon if you're into using Amazon. A lot of the stuff you get from Amazon is going to just be something no name from China. But I mean, that's not a big deal, actually. For most of what we need in our labs, that's not going to be a big deal. So whether you get it from Amazon or something like Jameco, it's not going to matter too much. This is the resistor kit that I recommend. It's $15 from Jameco. I think they do have it on Amazon as well. This is called the Velleman kit. And this is known as the E12 series kit. So E12 means that there is 12 values per decade. Let me pull up one note real quick to write something down. So the E12 resistor series is common, and the E12 resistor series says there's 12 values per decade, and they follow this sequence. So 10, 12, 15, 18, 22, 27, 33, 39. Oops, forgot one. 47, 56, 68, 82. So if I did that correctly, there should be 12 values listed there. Okay, looks like I did it right. And then it would just roll over to the next decade, which would mean multiplying everything by 10. So the next series of resistors would be 100, 120, 150, all the way down to 820. And then it would just roll over to the next decade. So then it would be 1K, 1.2K, 1.5K, all the way down to 8.2K, then 10K, 12K, 15K, all the way down to 82K. And then this should be pretty much the last decade that you have to deal with. So then you'd be in the 1 mega ohm, 1.2 mega ohm, and so on. So that's called the E12 resistor series. So E12 because there's 12 values per decade. So this is 1 decade of resistance. This is another decade of resistance, and this is another decade of resistance. So you can see each one is just multiplied by 10. So 10 to 100 to 1,000, 10,000, 100,000, 1 million. This is the most common sequence of values. So when someone says use a standard value resistor, what they're talking about is using something from this selection of resistors. So there are other series. There's like an E24 series, and the E24 series, as you know what the 12 means. So you can probably imagine what the 24 means. 24 means there's 24 values per decade. So basically in the E24 series, there's going to be more values filled in here. So there's going to be some resistances that land in between these values that you see here. And I don't have that one memorized. That one's not as common. But the E12, when someone says standard value, this is what they're talking about. This is the one that comes up more and more. And generally speaking, if you're buying resistors from the E12 series, they're going to be cheaper because they're more commonly used. But there are other series. There's E24, there's probably E48. I know I've seen E96. So if you want to spend a little more, you can get all kinds of different values. But these are what we call the standard sequence of values for resistors. So the kit that I'm recommending that you buy for the lab follows this E12 standard. Where'd it go? This one right here, it says E12 series. And if you looked at the way the values jump here, it says, 10, 12, 15, it's basically the same thing as I just wrote for you. I think that's the first 12. And then this would be the next, where is it? Up to 820 would be the next 12, and so on. And then the last decade they give you would be, where is it? Right here, 100, 120, 150, 180, 220, 270. Yeah, so that looks like a complete decade there. And then 1 mega ohm, they don't give you anything above 1 mega ohm, which is fine. So that's what that term E12 means. There's 61 different values in this particular kit, and these are 1/4 watt resistors. So it's important to make sure you understand what that means, right? So 1/4 watt is the maximum amount of power that this resistor can dissipate. So resistors don't have a max voltage or a max current printed on them typically. They have a max power because it's going to matter, the voltage multiplied by the current is going to determine the power. So it's not, so what we're more interested in with the resistor is the power, not so much the individual voltage or the current. It's the product of the two that makes the power. So the resistor kit we're using is a 1/4 watt. So if you didn't already know, when we have the other power equations, right? I squared R and B squared over R. So typically when you lower the value of resistance, you're actually going to be lowering the power. You're going to be increasing the power. That's not exactly obvious. So for example, if I looked at this equation, what I just said right now was I said, if you lower the resistance, you're going to be increasing the power. That's what I just said, right? So if you look at this equation, that's a little counterintuitive, isn't it? Because I just said that if you lower resistance, you're going to be increasing power. So look at this equation. It's multiplied by R, right? So if I took R as 10 ohms versus R as 5 ohms, you'd say, okay, well, the 10 ohms should have more power, right? It's actually not necessarily true because the resistance itself is also going to change the current, right? So the current is also going to change. So, assuming that you have a fixed voltage, this equation would be more appropriate to use because this will tell you that the resistance is actually in the denominator here. So it still applies with this equation. It's just a little trickier because R is also going to change the current, right? If I lower R, for example, then I've made I bigger. Wouldn't you agree? And if I made I bigger and I is squared, that's going to dominate. So that's going to increase the power at a faster rate than R is going to be reducing it. So in that case, if you lower R, you're going to increase I. And since you're squaring I, that's going to have a big effect. So you will be lowering this part of the term, but you're going to be increasing the squared part of the term at the same time. So if you have a smaller resistance, it's going to translate into more power dissipation in general. So higher value resistances are going to be well below the 1/4 watt usage mostly. But when you get down into resistances of like tens of ohms, or maybe 1 ohm, 2 ohms, 5 ohms, something like that, that's when you're going to get a very large amount of current, and that's when your resistors are probably going to start getting hot. So we just want to make sure you always stay under 1/4 watt of dissipation. That's what the meaning there is. So you'd have to calculate that yourself for any given circuit. So if it's just a single resistor, if you have, just a single voltage source and a single resistor, that's pretty easy to calculate, right? If you had, let's say, 10 volt source and let's say a 22 ohm resistor, you could figure out what the current is. You could say, okay, the current I is, 10 volts over 22 ohms, figure out what that value is. And then you could just take that current and multiply it times the voltage. Seems high. Maybe I just made these numbers up. 0.45, 10 over 22. Yeah, that's right. 0.45. 0.45 times 10. Yeah, I think I did that right. I just chose a really small resistance value here. You can see the power dissipation would be way too much. All right, so at 10 volts with a low value resistance like this, the power dissipation would be way too much. Let's just double check that, do it the other way. So I could also use the V squared over R calculation here. So if it's 10 volts squared divided by 22, that would be 100 over 22. So this is the same calculation I just did, right? Basically, the decimal point's been moved over. Yeah, 4.5 watts. So obviously this would be well above the maximum wattage of 0.25. So yeah, again, my point is that if the resistance gets too low, that's when you're going to start running into power issues. That's when you're going to start exceeding your maximum power. So that's going to happen when the resistances are low. So if we deal with, that's why you see most of the time we deal with hundreds of ohms, kilo ohms, tens of kilo ohms, hundreds of kilo ohms. You typically don't see anything down in the ohms, just 1 to 10 ohms or 1 to 100 ohms even. You typically don't see those resistor values very often. Those are only in certain specialized circuits. That's not to say that you couldn't have a 22 ohm resistor that wouldn't get too hot. You would just need to buy a much better resistor, right? So this one, the one that we buy in our kit, is only good up to 1/4 watt. But you could also buy a 5 watt power resistor or a 10 watt power resistor. So they tend to call them power resistors when they're going to be dealing with that kind of a power dissipation, because they're going to get quite hot. So they're going to need to be very large, have a large surface area. And in some cases, they're going to also require a heat sink to keep them cool enough to operate. Okay, so that's one option for your resistor kit. There's another option here. I think this one was the $15, the Velleman E12 kit. We also have, this is a slightly cheaper option at $10 instead of $15. It has less values. I think the other one had 600 pieces. This has 350 pieces. The other one had, I think, 100 and something different values. This one has 70 different values. So this one is a little bit cheaper, also from Jameco. There's some Amazon options I put in here. I looked kind of carefully through the Amazon options. A lot of them were kind of not very good, in my opinion, because they didn't have the right sequence of values. So a lot of the ones I saw here, they only had like 100, 220, 470, 100, 220, 470. They didn't have like anything from the 300s or 500s. So this one is on too much, in my opinion, actually. This one has like too many different values. So it has all of those E12 values I was just describing to you, and then some. So you can see 2 ohms is an extra one in there. 2.4 is an extra one. 3 is an extra one. 3.6 is extra. 4.3 is extra. 5.1 is extra. This one has a lot of extra values. This one would probably be closer to like an E24 series. But even though it's got all these extra ones, it's similarly priced to the Jameco kit I was showing you. So if you prefer to order on Amazon, you can get something like this. I guess it also has a coupon right now, 8% off. So this one, yeah, like I said, it's kind of overkill. There's a lot of values. Like, we don't necessarily need all these values, but this one has too much and the other ones have too little, in my opinion. But You can decide whatever's best. This is nice because they have the values actually printed on there on that tape. If you see it on the bottom right there, it says 43R. So that's going to be handy as far as tracking down which resistor value is which. So that's another option. Oops. And then the last option here, I have not tested any of these, by the way. These are just from what I've found on Amazon last night. I myself have used the Velleman kit in the past. All right, so this one's seems like a bigger kit too. I think this is nice because it has a convenient kind of little storage case there, so you can just stand them up, keep it somewhat organized like that. And then they also have the values printed nicely on there in little bags for each one. I don't know, little bags might be kind of annoying over time, but this one is $18. And it looks like it has the correct sequence of values here. There's maybe some missing, like there should have been, that should have been 33, I think. Yeah, this one should have been 33. And there should have been a 27 right there if it was the standard E12 series. So that can be a little tricky because sometimes, I might assign a lab where, maybe you need a 3.3K or, well, I guess this one has, does it have? Yeah, that's probably I don't know what the hell that means. 1K, 2K, 202, and 303, and then 4.7. That's probably a typo. It's probably 2.2 and 3.3, I guess. So you probably hit the 0 key instead of the period. Yeah, so you should try to get something that has the standard value. I think this probably does have the standard values. It probably just has a typo here in the description. Anyway, there is also some resistors on campus. So if you're in a jam, I can probably grab you a particular value of resistance, but in general, you should try to have your kit. So you're going to use this kit for other classes as well. So it's good to have for all your classes moving forward. Okay, so that's resistors. So that's the first thing I would like you to purchase is the resistors. The next thing would be breadboards. So I have some options here for breadboards. So a breadboard is going to actually hold your circuit. It's what we're going to put our circuit on top of. Maybe even Amazon, I would say is probably a better option for buying breadboards. They seem a little more pricey here on Jameco. In general, breadboards are pretty expensive though, in my experience. All the breadboards I've bought over the years, they always surprise me about how much they cost. But anyway, this is a decent size. So this size would be okay for this class. This is an 830 point breadboard, which means there's 830 dots basically on here that you can use to make connections between circuit components. So you're going to be putting your resistors and transistors and diodes and all that stuff on this breadboard, hooking up power and ground, and then you can measure voltages and current on it. So you need to have these for other classes as well. Excuse me. The minimum I would recommend is something like this, an 800. This is an 830 point, the long rectangular one. This is about the minimum size I'd recommend. Many students actually would go with the bigger one. So I have in my syllabus here, I also have some bigger ones. And most of the students in our program in the past would have gone with something like this bigger one. This gives you more room. I mean, this one's quite pricey though, $35. But it is nice to have the extra space. And it's also nice to have these banana jacks on the top. So you can use the banana jacks to make connections to the power supply. And then you can just stick a little jumper wire that goes from like this red one onto the breadboard. So I'll talk about how the breadboard works in more detail next time in case you haven't seen it. I think those of you who had me in 1021, I did actually turn on the camera that one day to show you how a breadboard works. I know that probably wasn't enough to really drive it home or reinforce how to use it, but we'll get a chance to do that in this course. So we'll go over that more when we actually get in person. But you want to have a breadboard for this class, and it's also going to come in handy for future classes. So if you want to invest in something bigger like this, feel free to do that. I would probably recommend doing that. I mean, over the years, I probably have 2 or 3 of these kind of size boards, and I have a bunch of the other smaller ones too. So if you want to get an assortment, you can do that as well. This is just like half the size of the other one I showed you, the rectangle. This is a 400-point one. So it's a good idea to have different variety of breadboards, but as a minimum, just get, if you're just trying to save money and get the bare minimum, then just get the 800-point one, I guess, for this course. If you want to invest in future classes, then I would get the bigger one. Or you can get a lot of the 800-point ones too. That's all that really the big one is it's just a bunch of 800. These are like the 800-point ones, probably all kind of glued together or tacked down to this metal backing board here. All right, so that's what a breadboard is. Again, we'll go into more detail about how to use it when we actually get there. I don't know how, I'm not sure about the quality of these Amazon parts, but this seemed like a better deal to me. I think you get 3 of the smaller ones. They look, I mean, it looks okay. The quality looks okay. I don't know like how it's going to feel. I mean, all you need to have is a good tight fit when you plug a wire into these holes here. This is only $8.99 and it comes with 3 of those. So that's a much better deal than what Jameco was offering. No worries about circuit failure. FAILIER. Yeah, I mean, they look fine from the picture. I mean, I don't know if that's the actual picture, or if it's just like a stock photo or something, but they look fine, and that's $8.99. So that's a decent Amazon option if you're into Amazon. And then I think I had one more. Oh, this is a typo. Yeah, it says resistor assortment kit. So there should also be a bigger one you can look for on Amazon that you can also find bigger ones on Amazon, bigger breadboards. Something got messed up with my syllabus here. There's a bullet point missing right here. Okay, so the next thing is supposed to be the wire kit. Yeah, wire jumper kit. So sometimes you can buy these all together. Like the breadboard will actually come with a wire kit. I didn't really look for that individually. Sorry, I missed a few comments there. Michael said just one breadboard. If you're getting the 800-point ones, I'd probably get a couple of them. I mean, it's always, at least I found it useful to have more than one. Sometimes in one class, you'll be working on one circuit, and in a different class, you're working on a different circuit, and they're kind of both works in progress. So I like to have more than one for that reason. But not everybody's going to need that, or maybe your partner has one and you have one or something like that. It's also a possibility. So you don't necessarily have to have more than one, but I do think it'll come in handy if you do have more than one. Yeah, so you also need to get a breadboard wire kit. So like I said, I didn't look for this, but a lot of times these come together with the breadboard. I think when I bought my first breadboard 10 years ago, it did come with a wire kit. I'm not sure. I don't think the ones I've showed you so far are going to come with any kind of wire kit. All right, so that's a good picture actually, because it shows you the 2 different types of breadboard wires. So these ones that you see kind of laying down flat on the board, those are called preformed leads. So those are leads that they've already bent the ends at 90 degrees to make nice, neat connections on a breadboard like that, like you see. The other type of wires you see standing up, kind of looping around, those are also handy for their own reason. I would probably recommend getting both types. If you want to make things easier in the long term, you can get by with just one or the other for sure. Like you can buy just the flat preformed leads, or you can buy just the looping leads. Either one. I personally like to have both because they each seem to come in handy at different times. So that's 2 different types of leads. So the preformed, and then I don't know what the special name is for the other ones, but they have like these plastic shroud connectors on the bottom. So that's those are 2 different types of breadboard wires, and I have some links to some on Jameco. I guess I didn't have any. You should be able to find this on Amazon too. I got tired and didn't search it anymore. I'd already spent hours looking through parts. So this is a typical breadboard wire kit. It comes in a little plastic box. It's got separators. So some of these wires work for like one pin space, like one grid apart from each other, 2 grids apart, 3 grids apart, 4 grids apart, another so on. So each one has a different spacing. So it'll just make connections at different lengths. So someone's posting a link. Okay. $12. Is this something you've used before, Arvin, or you just found it right now? You have that kit? All right. Okay, so this kit comes with both types of wires. I assume that's why you're recommending it here. So that's good. Yeah, that looks like this kit would do the same. Yeah, it comes with the preformed leads on the right, and then it has the loose ones on the left, and then some tweezers also to help pull them out of the breadboard. All right. Yeah, that seems like a good recommendation. Thanks, Arvin. So you can take a look at Arvin's recommendation also. Again, I haven't had to buy any of this stuff in a long time, so I just kind of did some searching on Amazon. So I'm not recommending any particular thing. So if you have any more recent experience purchasing, in the past, like I know I never made any recommendations, and everyone just kind of bought the cheapest thing on Amazon or something, and sometimes that turned out fine, and sometimes it didn't turn out fine. But so I thought I'd just try to go look through and make some recommendations. But it looks like that kit Arvin suggested is a good price for having both types of wires. All right, I think the last things here is the alligator to banana wires. These are typically quite expensive. Sometimes these can be like $5-10 for like one wire. It's ridiculous, I know, but those can be quite expensive. So this one is $11. Oh, this one's $11 for a pair, I guess. Yeah, 2 wires. So that's roughly $5 each. This is a banana to alligator wire, or yeah, I guess a wire would be the best name for it here. So it's got a banana plug on one end and then alligator clips on the other end. And then this is what you'd call a shrouded alligator clip or insulated alligator clip. So they put a soft silicone insulator or something around this to prevent it from shorting out to the other one. So a lot of times you'll have this sitting on your bench or something, and you don't want the metal on this wire to touch the metal on that wire. So you keep them covered with that shroud to make sure they don't accidentally touch together. So these are, like I said, these are quite expensive. You want to try to get one that's a decent gauge, like the 18 gauge, I think is pretty standard for the good quality ones. They have other ones that are 20 and 24 gauge. You don't want to buy those because they're going to be more voltage drop. Basically, they're going to get warmer. Like if you push a good amount of current through the higher gauge ones, then it's going to get warmer. And there's one brand called Pomona, which is probably like the industry standard for those. And they're very expensive. They're like, like $7 probably each wire. I used to buy those at Fry's, but now Fry's is gone. But I know, when I probably have spent, $50 or something just on these kind of wires over the years, different lengths and different colors and stuff. But all you really need is red and black. So we're going to use this for the power supply. In other courses, it would probably be helpful if you had a third one, so that way you can get positive and negative and ground all at the same time. But for this class, this is okay, something like this. I don't remember if I have any Amazon. Okay, so I do have an Amazon link here. So again, I have no experience with these leads on Amazon or even the more recent Jameco ones. I'm just looking at reviews and reading the specs. This one does not list the gauge of the wire used inside, but people were saying in their reviews that it would get a little warm at 10 amps, and a little warm at 15 amps, and 10 amps it was okay. So I think one of the reviewers did actually cut one apart and see what the gauge was, but they didn't have a way to measure it, so I don't know what the point of that was exactly. But they seem decent quality. It's good price, $12.99, and you actually get 5 of them, and they're 1 meter long, so that's like 3.3 feet. So that's a decent deal right here. So yeah, these seem like a decent option. I don't necessarily know the fit. Like you want this to fit snugly in the power supply. Sometimes the banana plug is too long, doesn't, and so it kind of sticks out, or it's not the right diameter, so it doesn't hold snugly. Hopefully that's not the case. Again, I don't really have any experience with these, but this seems like a decent option. So you want to get ones that say that they're capable of a high level of current, like maybe the 10 amp ones or something. And I think I looked up the Pomona connectors, and they're actually like a 18 gauge. So this is probably also an 18 gauge wire. And so that's a couple options for that. So what we're going to use this for is we're going to plug into the power supply. So the power supply has a banana jack, and then typically you're going to use the alligator side to connect to your actual breadboard's part of the circuit. So it'll have a banana jack on one side and an alligator on the other side. So this is called the alligator side, and this is the banana side. You can also get banana to banana cables. So I have both myself, and that's going to come in handy when you have the other type of breadboard. Like if you have this type of breadboard, then you can get away with just using banana to banana. Okay, because you can just plug the banana on the power supply and then bring the wire over to here and plug it in there, and then just use a little jumper wire to connect from this port onto the breadboard. So I can show you how to set that up if you want. It's actually not that intuitive. Like when you buy this breadboard, it's going to come with these things loose. These little connectors are going to be loose. Or maybe you can look online to see how to set it up. You want to make sure you set it up so there's the plastic insulator on both sides so that you're not actually... I've seen a situation where a student didn't set it up correctly, and basically the metal on this connector was touching the board, and the metal on this connector was also touching the board. So it's just a dead short to each other. So you want to avoid that. It comes with a little insulator, a little insulating piece of plastic, and you need to put that on there to actually make this insulate from the board. The way you're supposed to connect to it is you just plug in a banana from the top, and then underneath, like you can unscrew this part, and there's like a little hole underneath, and then you can screw it back down, and then it'll clamp on a piece of wire. So you can take a piece of wire, clamp it in right there, and then just run the wire onto like this red strip, for example, and then you can distribute that power around your board. So my point here is that if you have a board like this, you can get away with just using banana to banana, or you could also just get a banana to alligator, and then you don't necessarily even need to use these ports at the top. So it's up to you how you want to approach that. If you have a board like this, then there is no banana jack, right? So you'd have to have banana to alligator in this situation. All right, so those are the essential things that you're going to need for pretty much any in-person lab that involves, building circuits. Typically, we would have students buy stuff like this in 102, 1021, and then they'd use it in 230, 2301, in 2041, and then also 2101. And in other, some of the 300 level classes, you'll use it as well. So if you want to invest now, you'll be using a lot of this stuff in other classes, and then you can also use this to just, tinker at home. You would need to buy your own power supply for that, but we can talk about that later. You can buy a really cheap, or even just go around your house and find any old power brick. If you want to talk to me about that when we get in person, you can just take any old power brick and get a little adapter. Probably would work fine for your power supply. Here's some of the parts that we're going to use, but you don't necessarily need to buy these unless you want to buy them for yourself. I'm going to provide these components to you during the lab sessions. So, I have quite a few transistors myself, but the stockroom, you guys probably don't know because most of you haven't been in person there, but there is a stockroom on the 5th floor of Building 9. I'm not sure what the status of it is right now, but they have a lot of components in there, a lot of common things we're going to need for our labs. So, things like these transistors, the 3904 transistor, which is like one of the most common transistors that you'll come across. Adjustable supply. Okay, so Arvin showing the power supply that he uses, $64. with the display to measure voltage and current at the same time. That's convenient. So if you want to do more tinkering at home, you can get a lab supply like that. But if you really want to go low budget, like I was saying, you can also just get a little cheap AC adapter. Yeah, when I was a student, actually, I made my own for a project in one of my classes. So I still use that one. I probably spent, $200 on it or something rather than the $60. So I probably spent 3 times as much for twice as less. Anyway, so back to these components. These components, I can get them for you from the stockroom and provide them to you on the day of the lab. So you don't necessarily need to buy them, but if you do want to buy them for your own prototyping or your own experiments, you can feel free to do that. So there's a transistor NPN type, a transistor PNP type. This is a standard diode. A 1N4148 is a very, very common part number. And then the 1N751 is a Zener diode. So we don't know what these terms mean yet, but I'm just giving you the part numbers. So again, you don't have to buy these. I will provide them to you. But if you want to buy them and play around at home, you can do that. All right. So I think that's it as far as physical equipment. So yeah, breadboard, wire, resistor kit, wire kit, and then banana to alligator. Those are the 4 things that you need at a minimum. And that's per group, right? So you don't necessarily, each student doesn't necessarily have to buy all this stuff. That's per group. So you can work it out. I mean, most likely you'll probably want to buy it anyway, even if your group member already has it. But if money's tight or whatever, then you don't necessarily need to both buy it. You're going to learn the most if you get your hands dirty, though, right? So you don't want to be the lab partner that never builds the circuit and always takes the data or something. You want to kind of alternate. One time one person build it, next time another person build it. So you want to make sure that you get that hands-on experience. It's only going to benefit you. Okay, so last thing on the syllabus here is a discussion of software. Many of you have already had me and already have these pieces of software. So PSpice, OrCAD PSpice, OrCAD Capture Lite actually was the specific type of the software. There's actually the virtual lab also. So there's the virtual laboratory. The virtual laboratory you can find if you just Google. Yeah, Brian, it would be good if you had them next Tuesday. And I might be able to get some spares for those who can't get it in time. But I would try to order your stuff pretty quick. Hopefully it would be here by Tuesday. If not, then I can probably loan you some stuff during that lab session. What was I? Lost my train of thought. What was I looking for? So software, something to do with software. OrCAD Capture, Multisim. Oh yeah, probably just, yeah, okay. Oh, the virtual lab, that's what it was. Okay, so if I just typed in CPP engineering software here, and you'll see there's 2 options that come up. It says software for students, and then it also says virtual software lab. So if you're on a Mac or something that you don't want to install some of this software on, you can use this virtual lab computer here. I checked it out I think over the summer, and it worked fine. So you can just come in here. It's called the Virtual Software Lab. Come down to engineering and choose the one that has the software you need. I think I can't remember which one of these it is. You can just read the description here. Engineering Lab 01. So Engineering Lab 01 has Cadence. Cadence is part of OrCAD. OrCAD is part of Cadence. So this is what you need for PSpice. So that's okay for PSpice. And then this one also has MATLAB. So MATLAB's not a requirement for this course, but that's useful. And then it also has Multisim. Okay, so this Engineering Lab 01 has all the software you need. So if you have a Mac or something and you can't install this Windows software on your Mac, then you can use this computer. Another option for Mac users is to just get a virtual machine, something like Boot Camp or Parallels. Install a virtual machine version of Windows basically on there, and then you can run this software on your Mac. So that's those some options for you. Most of the engineering software is going to be for Windows only. That's probably changing over time. I mean, there's a lot of Mac users these days, so I think that trend is slowly reversing, but probably not by the time you graduate will the trend have reversed. Okay, so that's another option for your software. I'm going to provide, I haven't put it up yet, but I'm going to provide the old version of Capture Lite PSpice on Canvas for you to download. Same thing like I did in 1021. Multisim, you can actually find if you just, maybe that link might be old. Oh, no, this is ni.com link. You can just download it from ni.com, and then you can get the key. The key to install it is actually in Google as well. If you go to the software for students and then go to Multisim and free login and download, and then they provide the key to activate it in there. So I think most of you have already done that process of getting PSpice and Multisim, but if you haven't, or if you're new to this course, then that's how you can take care of those things. And then MATLAB, again, not required, but it's useful to run calculations. All right. So I think that's most of what I wanted to say in the syllabus here. Another thing, what they used to tell me is that I could start the lab at 9 if I wanted. They just kind of always schedule it for 8. But in the old days, it used to be like Mondays and Wednesdays labs were at 8, and then the Tuesday, Thursday ones were at 9 or something. And then at one point, they just started scheduling them all for 8. But a lot of students didn't like that because lectures always don't start until 1 o'clock. So you have all the way until 12, so 12 to 1 could be lunch, and then 9 to 12 could be the lab. So why start it at 8 makes everybody have to get up an hour earlier, and traffic's worse and things like that. So oftentimes we would move it to 9 o'clock kind of unofficially. Is that something you guys would like to do? Anybody? I mean, everybody should be in the lecture at 1 o'clock after, right? So there's no reason not to, I guess, unless you're doing something between 11 and 12. Because the difference would be 8 to 11 or 9 to 12 as far as the lab. I mean, we're not going to be there for 3 hours most of the time. I mean, most of the time, we're going to only be there probably an hour. Okay, so I'll make that official. I'll send an announcement about it, but I'll say let's unofficially make that 9 o'clock meeting time. Yeah, so next week on Tuesday, we're going to be meeting at 9 o'clock in our schedule, whatever our lab room is listed on Bronco Direct. And try to get as much of this equipment as you can by then. Our first lab, we're going to do some stuff with diodes. Again, there is some stuff around campus, so if you can't get your equipment by Tuesday, you should still come anyway. I can probably give you some loaner stuff to get you by for that one lab session. All right. I don't think I have anything else to say today. Is there any questions? Okay. Yeah, let me know if there's any questions. Send me an email, reach out to me. And I'll see you guys for lecture later, and then I'll see you in person in the lab next week.